Okay, hi everybody. Today we are going to start chapter 5, and we're going to split chapter 5 up into two sections. We'll test over the whole thing, but there are really two separate pieces to this chapter. The first part of the chapter has to do with what are called identities. So you are to have memorized some identities in your textbook, and we're going to be using those today. Your understanding, your memorization of those identities is going to make what we do today a whole lot easier. If you don't memorize them, it will be like everything else. You'll struggle. So let's lay the groundwork. Let's make sure they're memorized, and then this stuff will seem a little easier. So here's what I mean. I'm on my note sheet, 5-1. This is page 39. And the very first problem is this. Now, a little bit of background information. When we write trigonometric functions to powers, like this says sine cubed, what that means is sine x cubed. The reason we write it like this is so that we don't need to put the parentheses in. Because if you don't put the parentheses in and you write this, that's wrong. That says something that you don't mean. This says let's find the sine of x cubed. That's not what we mean. We mean we want the sine of x and we want to cube it. So we're either going to write it this way or we're going to have to include the parentheses. I will always write it this way because this is the way mathematicians write it. But you are free to write it the other way as long as you have parentheses around the sine x. So here's what I want you to do when you look at this guy. And it is big and scary. There's no question about it. I'm not going to make apologies for it. It just is what it is. But you can handle it. I have sine cubed here. And I have sine here. So what I'm going to do is factor out a sine. Just like I would factor out in any problem. Like if I had a cubed plus ab squared. If I had that problem, I would say, oh, I have a GCF. I can take an a out. I can take a sine out. I have a sine in both halves of the problem. If I pull that sine out, then what do I have left? Well, it's just like over here. If you pulled an a out, you'd have a squared left and b squared. So what about over here? If I pull out a sine, I will have sine squared plus, now I'm pulling that out, cosine squared. Now at this point, firecrackers are going off, bells are ringing, you're so excited. Because one of the things that you have memorized, one of your identities, is sine squared plus cosine squared equals 1. That's in the green boxes that you were to memorize. So this, as big and messy as it looks, is just 1. So I have the sine I factored out, and then I have a 1. So this problem simplifies to just sine. Your task in these is to simplify. That's what the directions say. So we did. We took this big, complex, ugly thing. We simply factored it, GCF, greatest common factor, took a sine out of both pieces, and we were left with just sine. You got to memorize this. No way around it. You got to memorize it. So if you haven't, do it. Okay, next, we have this. Oops. Now, when I look at this and you look at this, there's no factoring that we're going to do, is there? It's not like that one. There's no GCF. But there are a couple of parentheses times each other. And oftentimes, when we have two parentheses times each other, what do? Yep, we FOIL. So I'm going to FOIL this. So I have secant squared minus secant plus secant minus 1. I'm FOILing. First, outside, inside, last. Right there it is. Now, nothing cancels. There's, I can't do anything like that. Well, actually, I can collect like terms here, and those do cancel. So I've got secant squared minus 1 over sine squared. Now, remember in that problem over here, when we got to this point, and I said firecrackers are going off and bells are ringing, well, the same thing should be happening right here. Because another one of those things that you had to memorize was 1 plus tangent squared equals secant squared. Now you're looking at that saying, well, wait a minute, Mrs. Ford, I don't see that here. Well, if we took this equation right here, which you are to have memorized, you got to memorize this. 1 plus tan squared is secant squared. If we subtracted 1 from both sides, we would have tangent squared equal to secant squared minus 1. These two are the same equation. You're not going to memorize those separately. They're the same equation. But when we look at it in this form, then we can see what? This right here is tangent squared. So this problem becomes tangent squared divided by sine squared. Now we're not done. We're not quite done. Another thing that you're to have memorized is tangent equals sine over cosine. Now again, kids, I'm just telling you honestly, you have got to memorize these things. This is the foundation. So all the problems are going to build on these things. This will not be confusing if you have these memorized. So I've got this problem says tangent squared divided by sine squared. That's what it says right here. But I know that tangent squared is sine squared over cosine squared. And I'm dividing that by sine squared over 1. This is sine squared over 1. Well, now I've got these fractions, and what do I do when I'm dividing by fractions? I multiply by the reciprocal. So I'm going to, now, see if I can squeeze it in here. Sine squared over cosine squared times 1 over sine squared. What am I left with? 1 over cosine squared. Now you are welcome to leave it as 1 over cosine squared, or you can write that as secant squared. That you should already have memorized. You already memorized that the secant is the reciprocal of the cosine. So 1 over the cosine is the secant. So again, it's perfectly okay to leave it like this, but it's also okay to write it as secant squared. So this big ugly problem here that we started with ends up being just secant squared when we simplify it. Okay, so let's review those steps before I have to erase and start in the next one. We FOILed, had some like terms there. Then here was the tricky step. You had to recognize, because of what you have memorized, that secant squared minus 1 is the same as tangent squared. And that tangent squared is sine squared over cosine squared. And then you did the division, the sine squareds canceled, and left you with 1 over cosine squared. They're not going to get any harder than that. That's probably the hardest, oops, it's probably the hardest problem we're going to do right there. All right, let's try the next one. Now, as you're looking at the problem, I want you to think about what you've got. Think about what we've got here. Don't we have, I lost my word somewhere. Don't we have two fractions subtracted from each other? And how do we handle two fractions when we're subtracting them? We get a common denominator. So my common denominator, I'm going to have to multiply this one by cosine, and this one by 1 minus sine. Now the denominators match. So we're doing what we've done always in our arithmetic from the beginning of our careers back in elementary school. When we have to subtract fractions, we're going to get a common denominator. We're going to make them match. So now they match. This one got times by cosine. This one got times by 1 minus sine. So now both of my fractions have this denominator. Now what about the numerators? What have we got up there? Well, let's see. This will be cosine squared. And remember, we write it like this, or we write it like this. Do not write this. That's wrong. Don't write that. Either write it with the parentheses, if you like that better, or write it like this, which is how you'll see it in your math book. So we have cosine squared. All right, minus. Okay, now this is a distribute, guys. So this is going to be minus sine x plus sine squared. I'm taking negative sine x times 1 and negative sine x times negative sine x. Now those bells, alarms, fireworks, everything's going off. Because right here in the numerator, you have a cosine squared plus a sine squared. And anytime you have a cosine squared plus a sine squared, you're going to turn them into a 1. So now we have this on top. That makes 1. We still have the minus sine x over this. Now what do you notice? Do you notice that these will completely cancel? So all we have left on the top is 1, and on the bottom, cosine. So that's good. You can stop right there. If you want to, you can think of that as secant, because 1 over the cosine is the secant. That's in one of the green boxes, but you know that one already. We've used that idea. So you know that one already. All right, now we have cotangent divided by cosecant. Now, cotangent. By definition, one of the things that you have memorized or need to memorize is that cotangent is cosine over sine. It is x over y, adjacent over opposite, reciprocal of tangent. So I've got on the top, I have cosine over sine. That's that. Now on the bottom, I have cosecant. What's cosecant? Reciprocal of sine. Reciprocal means 1 over. Flip it. So instead of sine over 1, it's 1 over sine. Flip it. Now I've got these fractions being divided. So I've got cosine over sine being divided by 1 over sine. If I wrote this fraction out longhand, this is what it would look like. So now I'm going to flip the second one, because that's what I do when I divide fractions. And what happens? Do you notice? Do you see? These cancel. And what am I left with? Cosine. So that big ugly problem that we started with, we go through our simplification process, just ends up being cosine. Now at this point you're thinking, oh my gosh, this is so hard. Yep, it's hard, but you'll get it with practice if you memorize your identities. If you don't memorize that stuff that I ask you to memorize, this is going to just be impossible. So please memorize. All right, we got cosecant over secant. Now, this one I put thetas in. If you're comfortable with the thetas, that's fine. Some people don't like making the theta, or they think it takes up too much room or too much time or whatever. You can change those to x's. There is absolutely nothing wrong with using x's instead of thetas if you prefer. Okay, so take a clue from the one we just did. How did I start? I changed these into what I have memorized in my boxes. So what is cosecant? I hope you're thinking reciprocal of sine. That means cosecant is 1 over sine. What about secant? Secant is 1 over cosine. Now don't look at me like you don't know what I'm talking about. Those are in the boxes that you're supposed to have memorized. So now I'm back to this deal where I have these two big fractions and I'm dividing them. So longhand, this would be 1 over sine divided by 1 over cosine. But I know that when I divide fractions, I flip them. So this is going to be 1 over sine. Flip the second one. Flip the second one. So 1 over sine times cosine over 1. Oh, shoot. Nothing cancels. If I just multiply straight across, I'm going to get cosine over sine, right? What's cosine over sine? Cosine over sine is cotangent. So that problem simplifies down to cotangent. And again, if you want to use x's, feel free to use x's instead of thetas. All right, this is number 6. Now, this is your first one like this. You're going to do a whole bunch of these before we're done. But your first one, you're looking at that thinking, well, that doesn't simplify. I can't simplify that at all. I want you to think about something. We have this really important identity right here. That's kind of the queen bee of the identities. That's the big one. It's called the fundamental trigonometric identity. It's a biggie. And it has a cosine squared in it, right? So what if I got this by itself? I would have to subtract this, right, to the other side. So if I did that, if I moved this over to here so that cosine squared was all by itself, what would cosine squared equal? You're moving that over to here. Wouldn't cosine squared, I'll write it up here, wouldn't cosine squared equal 1 minus sine squared? If I wanted to get this all by itself, I would have to subtract this over to here. And wouldn't it say 1 minus sine squared? So that's what I'm going to do. I'm going to change that cosine squared into 1 minus sine squared. Now right now you may not have any idea why, but hang on to your hats. You're going to see in just a second. Anytime you see a cosine squared, gotta be squared, gotta be squared. Anytime you see a cosine squared, you can change it into 1 minus sine squared. I want you to think back to Algebra 1. You had problems like this, where it was a square minus a square. And we factored that. Do you remember? The difference of squares. We factored it as a minus b, a plus b. And anytime we had squares, we did that. So if we had 1 minus x squared, 1's a square. So we did 1 minus x, 1 plus x. Remember that? Look what we have here. Don't we have 1 minus a square? It's the same thing as this. So how is that going to factor? This factored into 1 minus x, 1 plus x. It's Algebra 1. How does this factor? 1 minus sine, 1 plus sine. And it's over 1 minus sine. Now, lo and behold, what's going to happen? And the answer to the problem is 1 plus sine. Ah, your head's about to explode. Hang on. It'll get easier. We just need to keep practicing, practicing, practicing. I promise it'll get easier. Get these memorized. All right, let's see. What was that? That was 6, so now we're on 7. I don't see anything we can factor there, do you? No GCF or anything. Looking at my list of stuff over here, and I don't have it all written down. You can look at your boxes in your book or in your notes if you've taken some notes over that. But this looks like about the only thing I might be able to do. Since tangent is sine over cosine, I might be able to change this into sine over cosine. Well, no might about it, I can. I can change tangent into sine over cosine. And you're thinking, Miss Ford, you're supposed to be simplifying here, and you're sure not making that very simple. Well, let's see what happens here if I keep going. So I changed my tangent into sine over cosine. Now these two are being multiplied together, right? So let's multiply these two straight across. So I have sine squared over cosine plus cosine over 1, regular old cosine. Now I'm adding. They're fractions. What has to happen when I'm adding fractions? They have to have a common denominator. So that's a cosine, that's a 1. I'm just going to make this a cosine. So now they both have a cosine in the denominator. What's up top? Well, that's sine squared plus, what's that? Cosine squared. Ding, 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 fireworks, buzzers, everything's going off because what's that? That's 1. So we have 1 over cosine, which is okay, or you can rewrite it as secant, because 1 over cosine is the same as the secant. You gotta admit, that's pretty cool. That's pretty cool. So, reviewing those steps, we changed the tangent into sine over cosine. We just multiplied these two fractions together. Then we got a common denominator so that we could add these fractions together. Then we had our identity, and we finished. Awesome, awesome work. right, here we go. Look at this. This looks like a mess. Let's see if we can figure it out. Now, think about the problem that we just did. When you look at this, I think it's pretty obvious. You're not going to be able to cancel anything. Nothing is going to cancel. How do I know nothing's going to be able to cancel? Factor. Factor. How do I know nothing's going to be able to factor? Because nothing's the same, right? There's no GCF. So think about what we did here. When we kind of had the same situation, we couldn't factor anything. What did we do? We changed our tangent into sine over cosine. And while I'm at it, I'm going to change my cotangent into cosine over sine. So I have cosine over sine times sine over 1, regular sine, plus sine over cosine times cosine over 1. Now all of a sudden, what do you notice right here? You're multiplying these two together. Don't these cancel? So that side is just cosine. What about this side? Just sine. You're done. Now, don't get carried away. There are no buzzers going off, no fireworks, no nothing. This doesn't add. Remember, if you're going to use the identity, they have to be squared. These aren't squared, but you're simplified. There's nothing else to do. You're done. That's the answer. When you get it down to sines and cosines, you're done. Unless there's some identity or something like that going on, you're done. This is an easy one. This is easy. Why is it easy? Because that's memorized. This right here is secant squared. And what is secant squared? 1 over cosine squared. Because secant is the reciprocal of the cosine. Now these are just fractions, and we'll multiply straight across. So I get cosine over cosine squared. Oh, I can cancel out a cosine. So I have 1 over cosine, which I can leave as my answer, or I can say that is secant. All right, now we've done a couple like this already. What is your thought? Do you have an idea on how to start this problem? I want you to think about it now for a minute. Do you have an idea on how to start this problem? Let's change tangent into what? Sine over cosine. So we'll have sine squared over cosine squared. That's our tangent. Now that's over secant. Secant is the reciprocal of cosine. So that's over 1 over cosine squared. I am simply rewriting tangent and rewriting secant. Now this is a division, right? So that's sine squared, if I write it out longhand, sine squared over cosine squared, divided by 1 over cosine squared. Which is sine squared over cosine squared times cosine squared over 1. gosh, guys, what's going to happen? And the answer is sine squared. So that ugly, ugly fraction that looks so complicated boils down to sine squared. Now, when you look at that problem, do you notice that there's a GCF? Did you notice you can take out a sine squared? So here's what happens. Regular factoring. You take out a sine squared, you'll be left with secant squared here, minus, if you take out the sine squared, just a 1. Beep, beep, beep. Buzzers, fireworks, everything's going off because right here, secant squared minus 1 equals tangent squared. So I'm going to rewrite this as tangent squared. Now I'm actually done at this point. I could stop here, but that's going to be a little confusing for you to understand because usually I keep going. So let me show you why it's okay to stop here and what would happen if you didn't, because not stopping is fine. If you didn't, the next logical step, if you didn't stop here, the next logical step would be sine squared times sine squared over cosine squared, because that's what tangent squared is, sine squared over cosine squared. Now, I'm just going to multiply, so I get sine squared times sine squared, that would be sine to the 4th over cosine squared. That's fine too. Nothing cancels, there's no other things you could do. Fine to stop here. Now, I knew, because I've done so many of these, that when I tried to simplify here, nothing was going to cancel. So if nothing cancels, there's no point in trying to simplify. Well, I knew that, but you're beginning. You may not have known that. So these are the steps you would follow. And then as soon as you got to here, you can see, whoa, those aren't like terms. I'm not going to cancel anything. So you would be done here. So here or here, either one, is a fine place to stop. In general, keep going till you get it down to sines and cosines and can't simplify anymore. So that would be down here. All right, number 12. Now this one is easier than you might imagine. It looks like really bad, really hard, but it goes back to what we were talking about a minute ago over here. We have, for a long time, since Algebra 1, we have been factoring squares. So if you had x squared minus 4, it would factor into x minus 2, x plus 2. Gang, you're supposed to know that. That's what we call in IB land, presumed knowledge. You learned that long time ago. X squared minus 4 is x plus 2, x minus 2. This is the same thing, only it's not just an x, it's a cosine. So it's going to be cosine plus 2, cosine minus 2. Just like x minus 2, x plus 2, this one's going to be cosine minus 2, cosine plus 2, in either order. Well, what happens then? Once you factor that numerator, we cancel, right? So the answer to the problem is cosine plus 2. Again, the key to this is just remembering how to factor your squares. Recognizing these are squares and then factoring them. There is nothing tricky or hard about that. Doesn't have anything to do with the trigonometry. It's all about the algebra, factoring and canceling. Okay, we're going to do just a couple more. Number 13. Secant squared, 1 minus sine squared. Now, just writing it down, ding, 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 those buzzers are going off because 1 minus sine squared can always be replaced with cosine squared. 1 minus sine squared can always be replaced with cosine squared. So I've got my secant out here, and now I've got my cosine squared, because 1 minus sine squared is cosine squared. What's secant? Secant, excuse me, is the reciprocal of the cosine. So I have 1 over cosine times cosine. What's going to happen here? You got it. That equals 1. So that ugly problem that we started with just equals 1. Last one, then I'll give you a break. Cosecant tangent plus secant. Now, is anything there a factor? I mean, is there a GCF? No. So, if we do what we've been doing with the other problems like this, we'll start rewriting things. For example, tangent is sine over cosine. Now what about cosecant? What's cosecant? Cosecant is 1 over sine. And what about secant? 1 over cosine. Remember, they're reciprocals. Don't these cancel? So this side is 1 over cosine, and this side is 1 over cosine. Wait a minute. 1 over cosine plus another 1 over cosine would give me a grand total of 2 over cosine. Or, back up a step, this is secant, that is secant. So we could write it as 2 secant. It doesn't matter. You can do it 2 over cosine or you can do it 2 secant. Either way, that's it. All right. Good work, folks. You got some studying to do if you haven't memorized your identities yet. And yes, we will be having a quiz over this. Have a great day.